Hello everyone. Today we'll be studying about the conservation of electric field. Conservation of electric. See, electric field is basically conservative in nature. Okay, I think I have told you in properties of electric field. Okay, conservative nature. What does conservative nature means? Means that work done in electric field uh, will be independent of the path followed. Okay, this means that work done is independent of path followed. Right. Okay, that means the work done will only depend on initial and final position. Right. Now, if you see that if we take a test charge here, let's say we are taking 2 points A and B. Okay, we are moving from A to B and then B to A. This is what? This is a closed path. Okay. Now consider a charge Q is placed in an electric field. Okay, and these are 2 points. Okay, so work done by the electric field to move a test charge from A to B. Okay, it will be, we'll find that. Okay, now to find that work done, sum of all work done for small elements, a small segment, if we consider a small segment set, let's say DL here, then we'll add all those and we'll get work done. Okay, uh, also uh, first calculate the line integral of the electric field from A to B will be E dot dl from A to B. This will be line integral of electric field from A to B, and line integral of electric field from B to A, it will be B to A, right? Okay, so the total line integral along the closed path will be what? The sum of this one and then the sum of B to A and sum of A to B. That means we need to add all these two. It will be E dot dl from A to B plus E dot dl B, right? This is what? The line integral, okay, around the closed path. Okay, so if you see from this figure, see here, VA minus VB, it will be minus E dot dl from A to B, and VB minus VA will be minus E dot dl B to A. And if you add these terms, what will happen? A will cancel out and this will also get cancelled out. From here you will get E dot dl from B to A equals to minus from A to B dot dl, right? So here at the place of E dot dl from B to A, you can write minus E dot dl from A to B. From here you will get E dot dl is equals to E dot dl A to B plus minus from A to B E dot dl, right? So this will cancel out by this, you will get 0. That means closed line integral in electric field is 0. So this gives us the proof that electric field is conservative in nature, right? So yeah, that's it. The next topic, uh, I think it's the equilibrium of soap bubble, or I think yeah, electrostatic pressure. Electrostatic pressure. uh See, suppose this is a thin spherical shell, okay, of radius, let's say r, and having charge distributed on the surface like this. Okay, now if you see that consider an area element dA here. Okay, and one more thing is given, sigma, that is surface charge density. Okay, then what will be the charge on this element? It will be dq is equal to sigma into dA, right? And you all know that electric field inside the in spherical shell is always zero, right? Let's say this is a point P. So here electric field at point P will be, obviously it will be zero, and electric field near this, let's say even near the conductor, it will be sigma upon 2 epsilon naught. Okay, even you can say, right? Now, if electric field due to this element dA, this even is what? Is it actually the electric field due to this element dA? Okay, and after, and we are doing one thing, we are removing this element, okay, from the spherical shell, right? So electric field due to the remaining part, let's say here E2, it will be what? This will also be what? Sigma by 2 epsilon naught, right? So the force on dA, force on dA, that is elemental area, it will be F is equals to E2 to dq. Q means what? E2 is the electric field due to the removing part, okay? Means the remaining part after removing the dA. Okay, so dF will be sigma upon 2 epsilon naught into dq, and dq can be written as sigma into dA. From here you get that if you move dA to this side, F by dA is equals to sigma square by epsilon naught, and dF by dA is what? Is that nothing but electrostatic pressure. Electrostatic pressure is nothing but sigma square by 2 epsilon. Okay, from this you can get one more thing, just a second. If you consider that it is a soap bubble, okay, soap bubble, then what will be the radius of the soap bubble? See, this electrostatic pressure will be what? Excess pressure due to the surface tension. Okay, and remember that for a soap bubble, excess pressure due to surface tension will be 4T by R, and this will be equals to sigma square upon 2 epsilon naught. From here you will get radius is equals to 8 T sigma, sorry, epsilon naught upon sigma square to the radius of the soap bubble, right? uh, yeah, that's it. And if it is not a soap bubble, means there is a water outside this, okay, I think droplet, okay, then this excess pressure will be P by R, and from there you can also find the radius. Okay, so yeah, that's all.